right? A lot of talk about carbon on the sheep and cattle side of things. So we have there's a project kicking off, and that's Sam Clark, who you'll see, and he's in animal science just down the hill from us. And we've had some contact with Christine around maybe working together on some projects coming up in the space. But between Sam and Julius Vanderwerf, they're going to measure 8,000 cattle and 10,000 sheep for methane in both feedlot and grazing conditions. So using green feed sniffer, using green feeds in the feedlot. This is the Talimba feedlot where they've got the grow safe, the cattle up grow safe, and green feeds, and then green feeds also out on pasture where the heifers are being raised. So that's the next phase. The industry is quite anxious to get results. We were at a meeting with some producers and we talked about these green feeds, and they're like, well, where can we buy them? Like how much do they cost? Where can we buy them? And we're like, well, they're like scientific instruments. You don't just spend $100,000 and just stick it out there and get numbers. We don't even know what you're going to do with them yet. So where does AgBoo get involved? So we're involved in the project, but once they have the data, it's how do we turn this into a breeding value, right? So that's kind of where AgBoo gets involved, in how a lot of demand at the moment in terms of changing our selection indexes to put these climate, whatever we want to call them, methane traits into a sustainability type index.
Anyone else doing this?
Yeah, everyone. Yeah, and around the world. Yeah, and actually, when I was in America with US Angus, we had some projects come up, but at that stage there wasn't the interest in it, I think, that there is today. I think it's changed in the last 3 years, kind of thing. Everyone's interest. So just I guess an Australian specific example of a project to come up with accurate genomic breeding values for cattle. In Australia, this is the Tropic of Capricorn. So, Armadale's down here somewhere. Armadale's actually the same latitude as Jacksonville, Florida, although I can't grow bananas. But if you go straight to the coast, you can grow bananas. It's just the fact that we're up 1,000 meters. But once you get up here above the tropics, of course, it's quite hot. If you're in the U.S., the Tropic of Cancer is somewhere off the Florida Keys, like the U.S. really isn't in the tropics, although we think Florida and Georgia and Texas and things is hot. But up here is serious tropics. So there's different breeds involved, but if we look at what's the economic, and they're Indicus breeds, see Brahman, for example, is heavily influenced there. And in some regions, only Brahmins would live. But what's the number one trait for Brahmins? It's basically reproduction. So, they don't have very good meat quality, but we don't want to waste any selection pressure on meat quality, or not much, because economically having cows calve every year is the big thing, especially when we get to methane traits. Having cows eat grass all year and produce methane and not produce a calf is not sustainable, really. So it's really around reproduction, and we've got Brahmins, we got drought masters, and we have Santa Gertrudis spread across these big research stations in northern Australia, and they're basically run as commercial operations. So, sometimes when it doesn't rain, and it hasn't rained at our house since November, so it's it doesn't look like this yet, but it will do someday, maybe, if it doesn't start doing this, and then basically it'll look like this. So it's whatever it does is what the cattle have to perform in. We put all the cattle head to head so we can compare the breeds. And it's all about getting this increase in selection accuracy with genomics for the fertility traits. So it's really intensive recording. So you think about those were huge properties of tens of thousands of hectares. And they're going to run the cattle coming up the heifers in every 4 to 6 weeks to scan them with ultrasound to get a corpus luteum to determine who's cycling. Because it's age of puberty in heifers, and it's first lactation and estrus interval from when they calf to the first time we see that she's cycling. So that's a lot of scanning to scan on those cows basically every month. But the benefit is it's very heritable. So here, age of first puberty in heifers is 55% heritable. And this just gives you an idea of the range in sire means. So this is their daughter's average age at puberty. So here's a bull that's somewhere between 15 and 20 months. And here's a bull that's well over 25 months age at first. That's a year different, right? Like these ones, you might have hope of calving them at 2 years of age. These ones are definitely not going to calve until 3 years of age. So there's a huge range. And you won't find that range unless you actually scan them. So, and I guess if you know your prefixes on bulls, but there's basically here's a breeder that's actually been very focused on breeding for fertility in Australia, and here's some breeders down at this end that are actually American bulls that the Australians aren't too happy about because they're bringing in all these. This is where the fertility problems are coming from. But this is the breeding values for age previous we got. Here's a bunch of the blues and Brahmins, the green Sandra Gertrudis, and the red is Drought Master. But we basically see at this end, which is the good end, there's a whole mishmash of breeds. So it's not that all the Brahmins are bad. Actually, the best bull is a Brahmin, which is interesting. But he's actually a bull that's from a research station that's actually been selecting for fertility for a number of years. So what's the project done? It's basically identified there's about a 20% difference in calving rate between these two bulls, and you wouldn't have picked that. Obviously, that bull I think was actually quite a popular bull. This bull might not be as big, but anyways, you won't find those differences unless you do the measurements. And just like the Wagyu heifer, now we have for days to calving, which is the fertility trait, a fairly accurate breeding value based just on DNA on a young calf like this. Actually, a fairly good breeding value. So we can avoid those 25-month plus bulls in terms of days to calving. So I'd like to jump in gear, so leave Australia for a minute, but back to a concept. This was a program we put together when I was at Angus, and it's basically a feeder cattle program. So it's about putting genetic values onto feeder calves. And I can remember having meetings in the basement of this building with this gentleman here, because he was running a feeder calf program here in the province. And we talked about a lot of these same things. Putting how do we put a genetic value on a group of calves? And what the advantage of that is it, as I see it anyways, it actually creates a pull for genetic improvement. So what we're doing is so here's a commercial producer. He's got a group of calves. Based on the bulls that he's used over time and the size of the calves, we can say, here's our prediction of the EPDs on the calves, and we can then put that into an index, and we come up with three different scores in terms of how they're going to perform for gain in the feedlot and how they're going to perform for payments on the grid in the packing house, and we put scores on calves. And now, when a feedlot buyer buys those calves and the ones that score better actually do better, he says, well, geez, those ones that score better actually do better. I can pay more for those. And so the commercial calf guy then says, you know what, those calves that are being score higher bring more money. I got to get bulls that give me calves that score higher. So, and then when they'll then start to drive up the driveways to the places that got the bulls that'll give them better calf scores. So it's really turning the whole genetic system, I think, upside down a little bit, because a lot of, I think, what we've done up to this point has been a lot of pushing genetic technology, like, you should record these things because they're important, and, you should genotype because you can get more accurate breeding values and make progress. This is actually the commercial guy then saying, hey, I want bulls like this because I'm going to get paid more. And this graph here, you can't really see it, but it's basically, that's the scores we gave the calves, and then that's how they performed in the feedlot. In terms of grid payments. So the ones that we scored better, actually, when they followed those calves through, did actually perform better. So the system is working. So there's kind of this, as I see it, there's kind of this push versus pull. I think we've had a push model for a while, and it's worked in some countries better than others. I showed you the genotyping rates and things for American Angus and the recording levels, but the recording levels and the genotyping levels here in Canada are actually quite a bit lower, which doesn't make a lot of sense when you think about they've got access to the same technology, they're in the same genetic evaluation, but we haven't seen the adoption here in Canada like we have done in other places. But I think we've got to how do we get people to adopt and change? I think if we can turn it into a pull model to get the commercial producers basically demanding it from the seed stock breeders, we'll turn it around. So, and I think I've referenced this spot 3 or 4 times already today, but I'll reference it twice more. And this, because I think I can remember, I remember standing about here on a seminar on a Friday, and Ted Burnside walked in, and he was the director at the time, and he looked, I was there, he goes, that that's this Canadian beef improvement has just started up. They're looking for a geneticist. That'd be a good job for you. And I said, well, I was a PhD student at the time. I think I had well over a year to go, or maybe 2 or something. I said, Ted, like, I'm still a grad student. Oh, okay. So, so Canadian Beef Improvement at the time was the sister organization to the Canadian Dairy Network, which is now Lactanet. The federal government basically privatized their genetic evaluation business, and they got out of the program. So the Canadian Dairy Network was formed. CCSI was formed for swine. This Canadian Beef Improvement, CBI, was formed for beef cattle. There's one for sheep as well. I can't remember the name. But the beef one basically died in about 3 years. It ran out of money, and they had a funeral. And that was the end of it. But things have come around again. So now we have in Canada, the breed associations have come together and forming something called CBIN. So it has a lot of, it's quite interesting to think, we're back to where we were in the 90s, but let's obviously we want to learn some things from what we didn't do back in the 90s. And I think with genomics, we've got better tools, and I think there's opportunities really to pull and this is what CBIN is promoting to do. It's really pulling the information chain from, we got a lot of information here. We've got some information here, and these ones at the moment are a bit like islands. You know, there's some feedlots have got good information, some cow-calf guys have got some good information, but there's no system that's really pulling it all together in terms of a national evaluation system for Canada. And I guess I go back to that pull model that we want to put. If we can put genetic values on cattle at this level, we can pull and create some changes in these bull breeders. So this CBIN thing is just really getting started. And so I think it'll be interesting to see how it develops here in Canada. So I'll refer to this spot for the last time because I did my defense, and Ann Gibbons was the chair at the time, and I guess you know the rest of the story because I did pass. And she said, "Oh, that was a good defense. You know, your presentation, that was good, Steve. But, you know, I had to answer a question, and the question was something like, you know, what's the future of animal breeding? You know, what's your prediction for the future or something?" I don't remember what my answer was, but I remember what Ann Gibbons told me, because she said, I think you've kind of like, you know, you'll be surprised, but I think in the future you'll see. And she described this model. And this is a picture I took from this paper, and you can look it up and read more about it. But it's basically what we call speed breeding or velogenetics. And she basically described this, and she said, "I think within your career, over your lifetime, you will be doing this." And at the time, I thought, well, that sounds a little bit out there, but this is getting closer. And so I think as breeders, so basically what it is, we can do this step now. We can take good cows and breed them to good bulls and generate some embryos. And we can obviously do ET and get some calves if we wanted. But what they're doing here is they're taking these embryos and they'll make embryonic stem cell lines from those. And then we can genotype those embryonic stem cell lines and say, okay, these are the ones we want, and these are the ones we don't want. And that is, as I see it, you know, keep in mind, when I gave my presentation, genomic selection, as I said, I thought that was a little bit fanciful at the time. So I didn't think this, but this is where good old animal breeding comes in. You know, we need to have good, accurate genomic selection to make this thing work. We need to be able to select the embryonic stem cell lines to figure out which ones we want. And then, as I understand it, there's been some breakthroughs lately of actually generating gametes from embryonic stem cells. So we can then take the embryonic stem cell lines, breed them together, and create more embryos. And then we can just start the whole process again. And the idea is maybe you'll do 2 or 3 rounds of selection, and then you might then take some of your embryonic stem cell lines and make some cattle and see what they look like and how they perform. Obviously, that would be hugely successful. It seems like this is all lab breeding, so forget about the farmers and forget about measuring cattle anymore. But that's absolutely not the case, because we still need to accurately select these embryonic stem cell lines. And to do that, we need accurate genomic selection. And to do that, we need good reference populations measured for the economically relevant traits. So I don't think this technology puts anybody in this room out of business. It may actually just accelerate and emphasis on the tools that you come up with, because there's going to be more desire now, or more pull from the industry in terms of, we need really good tools to select these embryonic stem cell lines, right? The other one, and this again is not new, because I remember presentations in this room. Sorry, I just referred to this spot again. Back when I was here, and people from the vet school working on this, not in cattle but in mice and other models. Basically, take a bull, you basically knock out his testes, and you're going to repopulate those testes with the DNA from another bull. That's basically what the technology is. Different people call it different things. I call it walking AI, because I see it as very similar to, you got a high genetic merit bull. Right now we collect semen, and then we synchronize breeding, and we go around and inseminate cows. Well, now we can actually have a bull that's going to walk around and breed the cows for us, carrying that DNA. I see this is, you can say, well, we've got AI now, so a bull will do it for you. What's the difference? I see this could actually really stimulate more corporate activity in beef cattle breeding, because if you think about how the corporate activity lines up right now in livestock breeding, you've got the poultry industry, you got the swine industry, you got the dairy cattle breeding industry, and then you got, say, beef cattle and sheep. So the dairy cattle industry right now, it's been, we have CMEX and we have ABS and Urus, and these other companies are getting bigger and bigger, because they can sell a lot of semen to dairy cattle all over the world, because there's a lot of AI going in, so the huge market. Well, in beef cattle, an individual company, because we got to sell walking bulls, we got to sell live bulls. You got to own a lot of farms and a lot of ranches to generate all those bulls. It's very expensive. It's even for big companies, that's a lot of money. So we got a very dispersed model. We got 20,000 Angus breeders in America breeding Angus cattle, registering them, selling bulls, and things like that. But now a company could, if they've got the best genetics, it's actually a way for them to really increase their market. So around the world, I see if this goes, could really stimulate bigger corporate activity. So it could be a threat to things like breed societies, I think, for sure, smaller breeders, and also what's the future in terms of inbreeding management? Because now, just like dairy cattle, we're going to suffer the same challenges.
You think it'll happen in your lifetime?
I think I bet you it'll happen in my lifetime in terms of, here's a bull, but then will the regulations get passed in my lifetime? That's my question. So just to sum it up, I think, again, genomics, I think, has been the big disruptor. And I think to get some of this genetic technology applied, again, to create that pull-through system from the commercial producer, and finally, some of these embryo technology, reproductive technologies could create some big changes. And I think, so I'm looking out there as the next generation, right? That they'll be dealing with that. Maybe, not that I'm that old, Brian, yet, but, and that's it. Thanks.
Steve, on the shedding, you want to talk about gene replacement?
Gene replacement? You mean like, yeah, I didn't touch on, you mean in terms of gene editing? Okay, so there is a, in catalog, there's this slick locus, right? It doesn't segregate in Angus. So one of the opportunities is, we can take the slick locus from Sentinel cattle or something and edit it into Angus. There is some of those have been created. There was an article, the Wall Street Journal had a video all about a red Angus heifer made in Brazil, because Brazil had the regulations to let them do it before in America. So yeah, that's possible. Again, it comes down to the regulations, but there's quite a bit of variation in Angus. So, and I'm not sure, like slick gets a lot of press, but I don't know like how much variation. So once you make them all slick, is there still variation? Right, there's in Australia, they've actually got a quite slightly different scale. There's a researcher in Florida that's working with Brangus and Angus and Brahman kind of thing. And so she's got Maltescu, Raluca Maltescu, I think is the, might not be pronouncing the name quite properly, but she made a presentation at BIF a few years ago, and I thought it was really interesting because she's basically analyzed the skin on those different cattle, right? And so she's got, you know, cross section slices of skin under microscope, and basically showing the difference in like sweat glands, right? So there's way more sweat glands in the Brahmins than there is in the Angus, and the Brangus are somewhere in between. So, you know, a thought that went through my head is, well, we've got these. So I didn't talk too much about that's one reference population coming together in Australia. There's another one coming together for the southern breeds. But should we be going to the packing plant and getting some skin on all those cattle and trying to look at the variation in sweat glands in terms of thermal tolerance, right? And then we have a genomic breeding value for, that's our reference population, right? We don't have to do it.
Do you think we're seeing more gene editing, perhaps with other economic important traits?
Yeah, and partly the reason I didn't talk about gene editing, because right now, with the exception of, say, slick, polled, color, some of these, you know, the simple inherited traits, I dare anyone to start making any edits. Like if I wanted to, although say at Angus, we have 1.25 million animals genotyped with 2.7 million ultrasound records, that we got a lot of data. And we have a genomic prediction for marbling, say, right? And so I could tell you that in the genomic prediction, that SNP's worth this much and this SNP's worth this much. So you might think, well, that's the SNP with the biggest effect, you know, make all the B's A's, that location. But that's not actually, we don't know that that's actually causative. That just happens to be the SNP on the chip. And we don't, so so they're really to take genomic selection to the next, gene editing to that next level, I guess, is we really have to know if you want to start making edits to change milk production or marbling or these kind of quantitative traits, what are the edits to make? And I think that will be the challenge for the people in this room. And actually, what I've showed today is really practical things about breeding value estimation. That's programs breeders are using today. As I visited with a lot of people here, stuff they're working on transcriptomics and RNA-seq and things, and those tools may actually get to let you make those edits. So that's even aside from the regulation side of it, but that's my thought on that. Yeah.
You see maybe with regards to the gene editing, I mean, you mentioned a really big drop in 2010 in bulls, right? So you could actually use gene editing to get rid of the known recessives, but it's a limited application, right? Only when you know exactly what you need to change could you use that to save a bull that has otherwise a really good polygenic score with regard, then you wouldn't lose that. But I mean, to do it the other way around, to change things in order to make an animal better for polygenic traits is going to be really difficult, if not impossible at this stage, unless you know everything about the 3 billion base pairs in the genome. I wouldn't start.
Right, I wouldn't dare start making edits. Yeah, that's right. Yeah. This is kind of a car analogy, I guess. But in terms of when I was a graduate student, I had maybe I was even a postdoc. Anyways, 1985 Mercury Grand Marquis, right? So, and back then the Ontario government had this like clean air program. You had to get maybe they still do. You have to get your car tested for emissions
after a certain year.
Okay, yeah. So anyways, my 1985 Mercury Grand Marquis needed to get its and it failed, right? So then the question is, well, we have to go away and try and get it over the line, right? So the mechanic said, well, actually what you can do is advance the timing, right? And it'll actually run a little leaner and it'll get over the line. So I got a timing gun, just to advance the timing a little bit. And but then your car like pings on hills, like, you know, your rattles on hills and stuff like that. Like it runs terrible, but it runs lean. And so then it passed the test, and then come back and then put the timing back where it was supposed to be. And I guess I use that example with gene editing, right? We have an engine that we don't really understand, right? How it all fits together. And you might say, based on our GWASs, oh, well, if we change that B to an A, we get this result, so we should do that. But yeah, that'll improve your emissions, but actually it's going to ping on hills and have all these other, and run too hot, and your engine won't last as long. And so that's as I see it, the problem is all these interrelated. The genome is very. We can't at the moment. We can't isolate these little cause and effects. Yeah.
Like whack-a-mole, right?
Yeah, that's right. Something else pops up.
Okay, so if anyone online has questions, you can turn on your mic or write on the chat and read.
Boston?
Yeah, I might say something. Something came to my mind about plant breeding. What you mentioned about the stem cells and producing the same animal. Actually, they do the same in plants, and it's not something too far to imagine. Like if we see a cornfield, all the corn in that field have the same DNA. It's selected and generate hybrid, and that's the same. Like animals maybe in future will be like that. This is the hybrid, this is the animal with this specific genotype, and the part of the variation which comes from the DNA, we can fix it, we will have more consistent product. Just a comment to see about that.
No, actually, just thinking about around hybrids and things. We think about chickens, right? So we've got, and you might not realize Brian Pogue over here is actually a poultry breeder himself. So maybe not hybrids, but so the lines of poultry are hybrids, right? You got two inbred lines and you cross them and you get the hybrid, and that's been highly successful. So back before I was a graduate student, people well, look what they're doing in chickens. That's been hugely successful. We should do the same in pigs, or we should do the same in beef cattle. Create these inbred lines and cross them and create hybrids. But obviously it didn't work because that's not what you see happening out there today. And where did it fall down? Is because you create these inbred lines, and cattle they don't have litters. You can't, like a chicken produces 200 something eggs a year, so that's a lot of progeny. We know we're going to get one from a cow. And so you created these inbred lines, and then the lines basically fell over in terms of fertility. So they weren't sustainable. As they got more inbred, they basically weren't sustainable in terms of replacing themselves. What they could do in chickens is you could have a lot of lines, and a bunch of those did fall over for fertility, but you didn't use those. And so you found the lines that actually, you succeeded in kind of fixing all the good alleles in a way. And got rid of those recessive. So the problem in the cattle and the pigs was, it's not that people didn't try, it's just that you couldn't actually keep the inbred lines alive. And we've got some people on the line here with more experience in this, and they may remember the history better than me, and I'd love to hear it if I've got it wrong.
And plus, Steve, the generation interval and the cost of each animal.
Right. And the cost of the animals, yeah.
Those major economical limitation.
Yeah. With this lab thing, we might surpass that problem because we can generate different cell lines.
Yeah, suddenly keeping those animals in petri dishes is a whole lot cheaper, right? That's a good point. Mostly. Yeah. So maybe, because I remember back there was, if you think about some of the companies like Pioneer, right, was a breeding corn and whatever. And you had DeKalb. DeKalb was breeding corn. But I think DeKalb actually had like swine lines as well. And I think Pioneer got involved with beef cattle at one stage. So there was, they thought, well, hey, this has been successful. Why can't we do it? Show these beef breeders how it's done, type of thing. But it obviously didn't survive the inbreeding problem. But yeah, that could be.
Also, I think the reality is the regulations in plants are completely different than in animals. Things that you can do in plants are not acceptable in animals. So I think that's why they are using Like one day I tell this for my students, I talk about people in the plant side about it would be nice to increase recombination rate, right? And they said, well, why you don't do this? Well, I said, well, how are we going to do that? Well, it's just apply radiation, right? Well, yeah, do that in animals, where are you going to end up, right? First, you will not never be accepted to do it, will not be approved the project, and you cannot use what you generate with that. But in plants, they do, and it's acceptable. So it's the regulations are quite different, and I think that's something mostly that even though there are examples there that we could use, but to translate to animals, we are going to be stopped by regulations nowadays.
Christine?
Can I ask a question? So
Yes, it's here.
So I'm intrigued by your PAP phenotypes. I think
Right.
that's fascinating. Super interesting stuff. But number one, what's the cost per phenotype for your guide?
Yeah.
And number two, do you see that as being like, is there any studies being done right now on the number of animals you need to have a reference population if you were to implement a genomic selection program for something like that?
So we have, go back here. I might as well look it up as opposed to telling you something and then having to change my story. So that's it here. So it's actually weekly. It's actually in the weekly evaluation. So the breeders do have a genomic. They can genotype animals and get a PAP breeding value now.
Yep. 31,000. Wow.
In Angus, yeah.
And that's one guy doing that all the time, or?
No, but it's either been done by him or someone he's trained.
Okay.
Yeah.
Okay.
And as I understand it, it's not that easy to train. It is an issue that how many people can you can actually can generate good data. Yeah. There's something else, kind of this trait. So it's obviously interesting to the breeders at altitude because, for the fellow that invited us out to his place, which was really nice. I saw him later, but he'd basically say he's become a bit of a, I don't know what you want to call it, the PAP whisperer, he would, because he said, for example, he notices this calf and it's it's hanging around down by the creek, right? And he says that calf's going to die because that calf's thirsty, right? And so as these animals, start losing fluid in terms of, but he said, for example, I said, how's it going? He's partway through calving or something. How's it going? He said, well, not very good. He started with, he DNAs, he puts in TSUs on every calf, as they're born, and they come in boxes of 10. And so of the first box of 10, he's got 2 calves still alive. He had lost 8 calves. So it's a pretty significant thing in that region. But there's another little phenomenon that's popped up lately, or maybe been more noticed lately, and that is what they call congestive heart failure, which is basically die of a heart attack. Similar, but a little bit different in feedlots. And so some of these animals are getting close to market, right?
That's already a feedlot. Wow.
So they're in the feedlot, right, and then they get close to market, and then bang, there's animals ready to get on the truck, and it falls over with a heart attack. But they basically start it the same way. Their shoulders start to spread, the brisket gets enlarged, their jugular gets distended, and they're basically, their heart blows their heart. So then the breeders are asking, well, is there any relationship between that and PAP? Mm-hmm. Right. And so that's the Colorado State researchers that kind of did a lot of the work behind PAPs. When you said you're impressed with mine, that's not my phenotyping. Someone else did all that work. Yeah. But yeah, I'm talking about. But so now what they're doing is they're actually scoring hearts in the packing plant. So they go into the packing plant and just with obviously cattle, they live to get there. But they score. So you have a nice shaped heart, that has kind of that, whatever shape that might be, upside down teardrop kind of thing. And then on the other end, you basically got this volleyball that's just about ready to go, right? So yeah, they made it there, but they're almost didn't make it there. And so that is potentially actually another phenotype.
Mhm.
And that's what they're working on now, is actually scoring hearts at the packing plant to get the heart scores. So again, at the talk, I gave a talk at the World Congress, but it was actually about welfare traits, right? And the point I was making is actually we do a lot. If you go down this list and you think about, okay, we got birth weights and calving ease, that's a welfare trait. We got docility, which I could argue is a welfare trait. We have a foot score with lameness, welfare trait. We got PAP as a welfare trait. Like there's actually quite a few traits that breeders measure now that are related to welfare. But that's a big one, obviously.
For sure.
Wow. But it's about 1 in 10. The problem is about 1 in 10,000 animals die of that congestive heart failure. So that's a lot of animals, but the frequency's not really high. That's the problem. Yeah.
If I get it right, you can tell the animal has coronary disease or blood pressure like that. That's wrong. It shouldn't be like that by the size of the heart. So why, like you're dealing with beef animals that you pretty much have an ultrasound every now and then, especially for marbling, for ribeye area, for example. Why not use the same ultrasound to measure the size of the heart? Is that even a possibility, or why it wouldn't work?
Yeah. I did have that Tim Holt. I did have this conversation with him about. I can't remember exactly how it's definitely been considered, I guess. And so without being the expert and giving you a good answer, I can say I didn't have that conversation with him. And then, he said, "Oh, geez, that's a great idea. Wish we should start doing that." It was like, yeah, we looked at that. For some reason, it hasn't been used. Whether is the heart too deep to penetrate with the ultrasound to get a good measurement? I'm not sure.
Okay.
Yeah, because the other thing is that it's a very invasive measurement. So why can't we come up with indirect measurements of blood pressure like we do in humans and stuff? But apparently they've tried all that too. So
Because you also said that the animal itself changes, right? Like the way the brisket is set also changes. So maybe as we have now with cameras and all that, it's probably one way to look at it without being too invasive, because as much as it's nice to be able to do that, the public response to that is going to be like bananas. People are going to what are you doing? Are you going straight into the heart of the animal?
yeah. So so we did pause the recording, and that was why, because that video I don't want to have out there, because could get misplaced or out of context and things like that. I think the answer to the people would be, well, this is a serious issue. So yeah, we got to do this to these cattle so we can prevent it in lots of others. So that's for the greater good. The problem with those bulls we ran through that day are yearling bulls, and they visually had nothing wrong with them. And it's total surprise for the breeder, and they've already got their eye on these are the cattle, these are the bulls we think we're going to be able to sell for a lot of money. They've got the best growth rate, they had great calving ease, the EBVs is all lining up good. Now we're going to do the PAP score, and number 2 in the sales fails, right? So it's not that number 2 in the sale was looking, his brisket was starting to swell or anything. They all look the same. At that stage, they all look the same, but their blood pressure was way different. So by the time that's the issue, I guess, is by the time they get to that level, then it's.
Okay. Any questions?
They take a picture of
Okay.
something.
Marie Hunt, what can you see in increasing accuracy of genomic predictions? And in meat animals, how important is consumer preference? So I think I did get to the increased accuracy with, or the increased response, I guess you'd say, with, and the accuracy values in terms of number of progeny equivalents. Yeah, how important is consumer preference? Obviously, that's really important, because I didn't, back to the whole Wagyu Angus thing, right? Certified Angus beef has, obviously consumers have got a preference for that, and they've been willing to pay for it, and that's been why Angus has taken off. So I think the other, we didn't talk at all about consumer taste panel and things like that, because basically it's marbling is driving driving that in as a correlated trait in the models. So we don't have tenderness. We've just put together a tenderness breeding value for Australian Angus based on research data. So that is, even though, you know, some opportunity to select for tenderness on top of marbling. Do you think gene editing has potential to depreciate traditional selection approaches? So I think we talked a little bit about gene editing. Again, for gene editing, I think it's, yeah, for the simple inherited traits, that's what we can do something with right now. But I think for selection, it's a ways off. In least developed countries, recording system for phenotypes is lacking. So is there any chance to build a sort of designer bull with gene editing to maximize all the desirable traits? So I would say no. Like I said, especially if a developing country, you know, some survival traits are going to be really important in terms of heat and ticks and fertility and those things. And yeah, lower heritability. I don't think we definitely won't fix that with gene editing. I think maybe with some of the, you know, the genomics could offer some things for developing countries, because what can we measure in non-developing countries to create the genomic prediction that could be applied in developing countries? Mike Loheis, they're also good protection for IP in plants, but much less so in animals. And I think that might have been, I guess, as we were talking about plant breeders' rights. Is that maybe what Mike was thinking about? I think if we look at just on that topic, I guess, I think we'll see a change in how companies and how breeders might protect their genetic material in a way. Like the history's been, I've got a really great bull, so I'll sell them to whoever has the most money, and then that person, you know, will produce other sons, and everybody's happy. But as a you know, on the corporate side, if you're in the poultry breeding business, you don't sell your grandparent stock to anybody, right? So, you know, and I think we hear, you know, I think some of the companies have already started to move towards, here's a great bull. We're not actually going to sell semen to the other companies. We're actually going to generate bulls, generate the next generation before we kind of turn the genetics loose. So I think maybe the IP issues aren't as strong in animals, but I think companies will start to get around them. As I understand, in livestock improvement company in New Zealand, you buy a dose of semen, you can breed a cow with that dose of semen, and you can keep a heifer from that. You can't keep a bull, right? So they don't. The purpose of you as a dairy breeder is to create heifers. You don't create bulls, and you can't genotype that dose of semen or send it away for sequencing or anything like that. So you sign a contract. So that's, you know, the beginning of starting to lock down the genetic material. Companies. That's it for online questions, I think.
Steve, I have a question. So this PAP score, how is the score? Like, how is it scored?
Millimeters of mercury. So it's the average. So if you take your...
So it's a continuous rate.
Yeah, so if you take your systolic and diastolic and take the mean, that's what it is. If you're 120 over 80, then you're 100.
It's a continuous score. It's not a...
Yeah, although we do in the analysis, because there's a big tail on the top end. And so we actually, you know, there's some transformation of the data. So, you know, there's, yeah. So I forget what the cutoff. I think the cutoff for, like, you know, if you're gonna select a phenotypically, it's like 70 millimeters, I think, or something.
But when you analyze, you say like a binary trait?
No, we analyze it as continuous.
Okay, so the 25% heritability is for that continuous.
Yeah. Yeah.
I was wondering, when you collect the phenotypes, the fact that you need to strain animal, you get like stated, does not change the evaluation?
You could, yeah. So besides kind of watching, I thought I'd help, you know, that day. So I kind of got on the halter for a while, but the owner was like, he's like, you know, you're pulling a little hard, you know, like kind of like take off the pressure a little bit. So that was part of it too, is you had to be a bit conscious of exactly that, right? The one was, you know, if you really crank on the head, then you're kind of cutting off the blood a little bit and things like that. So yeah, you had to be a bit consistent, but there's really no other way to do it, really.
Is there a correlation with the zoom?
Well, that's a good question. Well, they did earlier. There was actually a master's thesis from Colorado State where they looked at all the, before we'd had the EPD, but they looked at all the genetic correlations, and nothing jumped out. At the time, I thought, well, the one thing that stuck out was it was kind of a minus 0.45 or something with, or plus 0.5, I forget what which way it was going, but it was basically with the maternal birth weight. I thought that's really weird. Maternal birth weight. Oh, that's just, you know, that's just some anomaly or something, right? But then as you get talking with Tim Holt, he's like, well, basically, if you have an animal that has any calving problems, they will have pap problems. So what he's saying is when that calf is born, if it's a difficult birth, the calf basically aspirates some amniotic fluid, which compromises its lungs. And then later in life, it's the one that has pap problems because it's at altitude, it doesn't get the air, and then it's heart. So so I thought, so then I kind of flashed back to that maternal birth weight thing, and I'm like, oh, well, actually, maybe there is something to that, right? It wasn't just some anomaly. So, but I don't remember anything jumping out about docility. Oh, sorry.
I was just wondering, so you mentioned how breeders are now starting to sell semen, and then you also mentioned how the earth is looking like a lot of like selection at the embryonic level. Would it then be up to breeders at that point to prevent inbreeding and bottlenecking the population? Because now if we're sending eggs in certain lines all over the world while sending semen lines all over the world, couldn't we essentially bottleneck the world's population?
Yeah, absolutely. Yeah. So that's, yeah, no, if you think back to that the little schematic there basically has one bull bred to one cow, and then you generate, but obviously we can't run a program like that. Like we can't generate the next population of cattle based on the same bull and the same cow. So there's got to be lots of those cell lines coming together. So yeah, very careful. I think that's very, very careful management of the population. It's going to be really important.
That would be up to the breeder more so to manage their populations like individually. Or would it be more of like government? I don't know.
Oh, definitely the companies, the owners of the animals. Yeah. 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 No, that's a really good point. And the same with the walking AI, you know. It's not that much of an issue right now because there's lots of genetics out there, but if we all start, you know, chasing a few really great bulls that we could just put their testes and everybody and just, well, the other thing with the walking AI thing is you could, let's say Northern Australia. So a company, Matt Kelly, he used to be a postdoc here in the building. He's gone on to work for Australian Agriculture Company, and they have one of the biggest breeding operations maybe in the world, but certainly in Australia. Hundreds of thousands of cows, but they're breeding cows in Northern Australia, but they're breeding them to Wagyu bulls. So here they've got cows that actually survive in the conditions. The Wagyu bulls got to survive long enough to breed the cows, and then the calves, you know, get into the feedlot. But you could have a Brahman bull up there that survives the ticks and the heat and everything else, but he's got Wagyu semen, right? So you could it really could open up the opportunity for more crossbreeding than you do today.
Online, those we have.
I have, sorry, go ahead.
No, go ahead. You had the idea, so I think they.
I was going to say, if we could take a picture, it would be really nice. If we could have the people who are online turn their cameras on and then have everybody in the room stand in the front, we can take a picture maybe of Steve while he's here, because he doesn't show up very often.
And it would be nice
A mythical creature.
because we have a historical picture that when Steve was the CGIL director, everybody aligned in here, and he wasn't.
I would love it. Yeah, that'd be great.
Well, he keeps talking about he was standing there when this happened. He was standing there when this happened. So now we have to catch him, right, with a photo of when he's standing there. I'm not sure if everybody wants to go up to the front, I don't know how we're going to do this, but we can try. That actually looks pretty good if I just leave it right here.
Oh, a timer.
Yes, please. There's Murray, Kayal, nice to see you.
Kajal?
So we need everybody to sort of go around Steve, I think, a little bit there.
Oh,
Actually, I'll take it.
that's awesome.
Oh my gosh, that looks cool.
Yeah. Okay.
Yeah, I'll get it.
Yeah, otherwise you guys change colors, right?
Like, are we blocking that?
Yeah, we're blocking them a little bit. So if we could split maybe a little bit around the screen.
I think we can remove stable for a second.
Yes.
Yeah, good idea.
And I'm going for water.
Yeah.
Get him in the picture. I think we need Antonio in the picture too.
No, I thought we take it.
So, but,
Yeah, please spread
Okay.
off to the side a little bit. And then we're gonna have.
Instead of throwing you, calling it over.
Oh, great.
Yeah, we need to like.
Oh, you're gonna have a stable next. Yeah. The next thing. My neighborhood has a apartment.
Oh, I think Christian is right here. Flying. Yeah, very good.
Cozy.
Okay, get.
Sorry, just let me close this and then. It's not.
Come.
Yes.
Vamos a poner aquí un momento. And you, Christine? It's okay. It's okay.
Christine, take one like that and then one like a selfie.
Okay, we'll take one like this.
Okay, so.
Sure, guys. in the front.
Oh my God.
Okay, yeah, in the meantime, I'll organize. Okay. So let me have some things to help you some talk, but still.
Three lines there, guys.
Yeah, we can do 3 lines. Oh, there we go, 3 lines, like a soccer team. Now we're just waiting for Angela.
Antonio should lie in the.
I will
Antonio,
go
how
now.
are you doing?
I don't have need to stay.
I'm gonna start just in case you guys use your phones, because that would be terrible. Because it looks beautiful. There we go, Olivia, good. Moving in. This is fantastic, this is the coolest picture ever. I phone a photographer. Fantastic. There's a photocopy room. Right here.
After,
Wonderful.
after Steve.
Yeah.
Oh, thank you so much.
Next to Steve.
You're like they're double. You see yourself right behind yourself.
Yeah, how's that? Then we have a real soccer
Oh.
team. 3, 2, 1. I got it.
Thank you very much.
Nice job.
I got it was online.
Hey, Jock. Yeah.
Hey, how are you?
Yeah. Oh no, oh
Yeah, everybody.
Yeah, that was fantastic.
You want to meet Steve, you?
Hi, Steve.
no. I think it's probably better. I think.
I'll make you have one like this. Sure, no, that's good. Okay. One point, it's like 34. Okay, really? Yeah.
Wonderful presentation, amazing number of.
In America.
So, was aware of his even temperament. Very, very good.
So we're friends.
Yeah, we're going back a little bit of my time. So I'm on Zoom most weeks with them.
Okay, cool.
Heavier.
Good. Thank you.
Well,
Thanks.
no worries. We'll pick Sean up the airport.
Okay.
Got another video.